Thanks, Peter. At Anthropic, we build trustworthy AI. Each day, millions of people around the world rely on Claude for their work. Claude writes code, edits documents, and uses tools to complete tasks. And I'll be honest, Claude wrote like half of this keynote I'm about to tell you. Now, thanks to our partnership with AWS, businesses large and small can use Claude on the secure cloud that they already trust. I'm going to spend some time digging deeper into how our collaboration works. First, let's talk about Claude 3.5 Haiku that Peter just mentioned. It's one of the newest and fastest models. Despite its small size, it packs a punch, sometimes matching the performance of our largest model, Opus, while costing 15 times less. As Peter mentioned, we worked together to build this latency-optimized mode that lets customers run Haiku even faster on Trainium2. This means, as of today, you can run Haiku 60% faster, no changes needed on your side. You just flip a switch on the API, and your requests get routed to the new Trainium2 servers. Easy. Now, this speed is great for in-the-loop interactions. So I'm a coder. Imagine autocomplete, where you need to tab complete the suggestions in the short time between keystrokes. A 60% speed up makes a huge difference here. It can be the difference between your completion showing up or not at all. So how did we make it so fast? Well, first off, look at this thing. It's a beast. Look at that machine. And then each of the chips in it has the serious specs that Peter told you, over a petaflop of compute in those systolic arrays. Plenty of memory bandwidth, fast interconnects. It's got great specs. But as every engineer knows, specs aren't enough. To get peak performance, we need to keep those hungry systolic arrays fed all the time. That means sequencing the work so that they're never blocked waiting on their inputs from memory, from the interconnects, from wherever. It's like a game of Tetris, where the tighter you pack it in, the cheaper and faster the model becomes. So how do we solve this Tetris game? Well, Anthropic's performance engineering teams have been working closely with Amazon and Annapurna on this challenge for over a year. We found that the compiler can do a lot, but it's not perfect. And at our scale, it's worth trying to be perfect. A single performance optimization for Anthropic can unlock enough compute to serve 1 million new customers. This means it's worth it to drop down to a lower level, like Nikki, and write kernels as close as we can to the raw hardware. It's like moving from Python to C for the most important parts of a program. And we found that Trainium's design is great for this type of low-level coding. So folks might not know this, but for other AI chips, there's actually no way to know which instructions are running in your kernel. This means you have to guess. It's like playing Tetris with a blindfold. Trainium is the first chip I've seen that can log the timing of every single instruction executed anywhere in the system. Let me show you. Here's an example of a real low-level Trainium kernel that we developed at Anthropic. You can see here exactly when the systolic arrays are running, when they were blocked. Plus, we see exactly why they were blocked, what they were waiting for. You get to take off the blindfold. This makes writing low-level kernels faster, easier, and in my opinion, way more fun. OK, speaking of fun stuff, I have something to announce. You see, so far we've been focusing on inference, but they don't call it Trainium for nothing. I'm excited to announce that the next generation of Claude will train on Project Rainier, a new Amazon cluster with hundreds of thousands of Trainium2 chips. So hundreds of thousands of chips means hundreds of dense exaflops, over 5 times more than any cluster we've ever used. So what does Rainier mean for customers? Well, the world has already seen what we've been able to do with our last cluster. Earlier this year, Anthropic shipped Claude 3 Opus, the smartest model in the world. 4 months later, we shipped Claude 3.5 Sonnet, even smarter than Opus at 1/5 the cost. Then, in the last month, we've shipped both 3.5 Haiku and an upgraded 3.5 Sonnet that can use computers like a human. Project Rainier will speed up our development even more, powering both our research and our next generation of scaling. This means customers will get more intelligence at a lower price and at faster speeds. Smarter agents that they can trust with bigger and more important projects. With Trainium2 and Project Rainier, we're not just building faster AI, we're building trustworthy AI that scales. Thank you.